This one we have two functions, and this is non-calculator because this is number 5. So f of x is going to be this quadratic function, and g of x is going to be a cosine function. And R is the region bounded between them, and you're told that, which is nice, where they intersect. And so first we're going to do is find the area of R. And remember, you're not going to be able to write on this question on your test. So it's a good idea for us just to kind of practice drawing it. That's not very good drawing. That's okay. Now we do need to know which is on top. So would you guys say F is on top or G? Definitely going to be G. Cosine of that is going to start off at 0. It's going to have a maximum at 4. And then it's going to be, the whole cosine would be something like this. So this is G on top. F is on bottom. F is an upward opening parabola. All right, and then they cross here at 2 and here at 0, 4. So A, we're going to find this area. To find the area between two curves, we are always going to do an integral. Right? What are my upper and lower limits going to be?
0 to 2.
Good. And then what's the order I would subtract these?
X minus that.
Good. Alright, and then I would guess you would get a point just for writing that with a G and the F. So I recommend doing that. It takes some time. But if, like, when you go to write it now, if you, like, mess something up writing it, you'll still get that point from writing it correctly the first time. So for G, don't forget your dx's, please. Right, and I was hoping eventually we would do one where we needed to do what we're about to do. Because we've been practicing them where we haven't really had to. Okay, so we're going to multiply by 4. And then we're going to find the antiderivative of the cosine of pi over 4x. Now, if it was just the antiderivative of the cosine of x, what would you say that is? It would be sine of x. But it's not that. So what you have to do is find the derivative of this. So what's the derivative of pi over 4x? What's the derivative of 2x? Okay, what's the derivative of pi over 4x? Pi over 4. So because that derivative is not just 1, you multiply by the reciprocal of it. And then you do the sine of pi over 4x. Okay. And then we're going to just do the antiderivative of that polynomial. Doing the power rule for antiderivatives. And then we're going to plug into a 0. And then we're going to stop. We're going to leave it super messy because that's what we do. This is kind of risky, actually, the way I did that. just because you're plugging in 0 doesn't automatically mean that it's going to be 0. So especially if you have a sine or a cosine. So just be careful. In this case, the sine of 0 is 0. But if it had been cosine, you couldn't just put minus 0. So just be careful. It's actually not a bad idea just to plug in all the zeros. It's okay if you do that. That was kind of risky. All right, you guys okay? All right, let's look at the next one. So for part B, we're going to write, but do not evaluate, an integral expression that gives the volume of a solid generated when R is rotated about the line y equals 4. So again, I'm going to draw it. You could use your drawing you've already done.
So will they want us to redraw it every time?
You don't have to draw it. You only draw it for your benefit. All right, that's the axis of revolution, y equals 4. I don't think you get any points for the drawing. I just need to do it for my brain. Okay, and so remember on this one, if there's any space between what you're rotating and the axis of revolution is going to be a washer. And for the washer, you need a big radius and a small radius. So from the axis of revolution, you draw a line to the closest point, not the closest curve, I guess. It doesn't have to be the closest point, the closest curve. And then you draw a line to the farthest curve. And you have a big radius and you have a small radius. Do you guys remember what you do to find the big radius? Or either one of them?
4 minus f.
Yeah, so this is F and this is G. You're going to do top minus bottom, so in this case is 4 minus F. And then the small radius is the same thing. Top minus bottom of your little line you drew. All right, and then for our volume, so for a washer, do I need pi? If it forms a circle, I need pi. So pi times the integral, still from 0 to 2. We're adding up all the washers. All right, and then what do we do for a washer?
Big radius.
Yes, squared. So big radius squared minus small radius squared. You're doing the outside circle minus the inside circle. And don't forget your dx.
And that's the same as writing it, like if you, never mind.
Don't do the whole thing squared. That's not the same. You're right. That's what we would do if, on the next question, if it had been a semicircle, that's what you're thinking. All right, our next question is actually a square. And so we have this same figure, the same region, and we have this solid that we're finding the volume of, and each cross section perpendicular to the x-axis, which is good. I probably should have you guys practice some that are not, but perpendicular to the x-axis makes a square. And we're going to write, but not evaluate, the integral expression that gives the volume of the solid. Okay, and so I recommend that you draw one cross section. So one of our cross sections is a square. Right? What is the side of the square going to be? It's technically this.
G of x minus
So the way I would do this is I always represent the area of one square or one cross section. In this case is a square. And that's going to be whatever the side length is. Squared. And so the volume, you're going to add up all the squares. All the squares from 0 to 2. But all of those squares area is going to be found the same way. So once you get that area, it's just the integral for that area. And that's it. So that's nice. You don't have to find anything. All right, what questions do you guys have about area volume?